Okay, class, we're going to be doing Thevenin equivalent circuit. So this is the original circuit that we're going to do. And this is A and B. So this is going to be our RL, which is our load resistor. The first thing we do with Thevenin equivalent circuit is remove the load. So we're going to put the load in the Thevenin equivalent circuit, which I have put over here. So we put the 400 ohms, which is the load. So basically what we're going to be doing is getting the voltage across the load resistor in the Thevenin equivalent circuit. This is RTH and this is VTH. I don't know if it's going this way or this way yet, so I just made it look like a capacitor, but it's going to be a battery. So the first thing with Thevenin is remove the load. The second thing is to get VTH, and VTH is basically the voltage from A to B, or A to B, any path that you take as long as you start at A and end at B. So this one is pretty simple. We have, because this is open, there's no voltage going here. There's two resistors and they are the same amount, and there's 10 volts each. So you're going to have 5 volts here, and you're going to have 5 volts here. The current is flowing clockwise, and you know we always enter positive and leave negative. Enter positive, leave negative. We basically just have a series circuit because of the open there. So now we can say the voltage from A to B is a positive 5 volts. But even if we go A minus 5 plus 10 is still going to be a positive 5 volts. So we come back to the Thevenin equivalent circuit, and we now know voltages go in this way, and we're going to have 5 volts. Current is flowing this way. Now we have to get RTH. With RTH, we basically short batteries and open currents. So this is the battery. We're going to short the battery, okay? Then we're going to put a pretend battery or an I here. It's either the look-back method or a pretend battery. So what do we see? If this was the battery and we were going to minimize this circuit, the first thing we would see is 500 in parallel with 500. Well, we know that if you have two resistors and they're the same, it's just half. So 500 in parallel with 500 is 250. That answer would go here, and it would be in series with the 500. So RTH is 750 ohms. So we put our RTH here of 750 ohms. We have our Thevenin equivalent circuit, so now we're going to use the voltage divider rule for VRL, which is the load. We're going to put E total, 5 volts, times what we want to get the voltage across, which is 400 ohms, divided by R total, so we could put 750 ohms plus 400 ohms. Once we calculate that, you should get an answer of 1.39 volts. So 739 volts. So it's approximately 1.74 volts would be your VRL within the Thevenin equivalent circuit.
You better check that. You said 1.39.
Okay, so we're good.